This next section is about confidence intervals for proportions. So far we've gone under the assumption that we actually know what the true value of p is. And what happens is that in reality, we don't know what the true proportion is. So we have no idea what this p is. And in the previous examples, we've kind of believed what the answer was. So, for example, Shaquille O'Neal, this is what we can say. This is what we believe. Well, here it says the lifetime free percentage rate. So someone went ahead and calculated this. But in reality, a lot of the times we don't know what that is. And or where exactly is it located. So what we're going to try to do is try to use our sample p hat to try to give us a possible range of values. So if you remember, here is the population, and the population has the true parameter p. So we can't possibly get every single person. So what we do, we gather a sample and give an estimate for p, and we call that p hat. So p hat actually here is what we're going to call my point estimate. So it is an estimator for p. Okay, so if everyone in the class got a sample, all of you guys are going to have different p hats. So which one is the true p hat? Or which one's the true p? Well, since a lot of you guys have a lot of different ones, well, everyone's going to have a different type of estimate. So having one particular value to try to estimate p can be a little bit difficult. So instead, we are going to try to find a range of values, a range of possible values of where p can be found. So this is what we're going to call confidence interval estimates. So we need a couple things. So the first thing that we're going to need is something called a confidence level. Okay. So my confidence level is just the probability that the procedure used to determine the interval will provide an interval that includes the population parameter. So this is going to be basically the probability of me trying to include or the probability that my interval includes that population parameter, okay? And there's a couple things that come with that. So I wrote them down in this table, and we'll talk about confidence level a little bit more right now. But so basically, a confidence interval estimate for the population proportion P based on sample size N from that population, which sample proportion p hat is given by this. So this is something that you really need to know. So make sure that you copy this down, put it on your cheat sheet, whatever you want. P hat plus or minus z star square root of p hat 1 minus p hat divided by n. That is my confidence interval estimate. And notice this plus or minus. So back in the day when you did quadratic formula, we had a couple things to work with this plus or minus. This is just basically plus or minus p hat minus z star square root of p hat 1 minus p hat divided by n. So that is our first bound, and then this is going to be my upper bound p hat plus z star square root of p hat 1 minus p hat over n. Okay, so this is basically the formula. The plus or minus means that there's one that's minus and the one that's plus. Okay, now here, my confidence level, so this is how confident I am that my interval will contain the true value. So in statistics, we tend to have three different types of confidence levels: 90%, 95%, and 99%. Okay, so this also put it on your cheat sheet. A 90% confidence level corresponds with a z-score of 1.645. A 95% confidence interval corresponds with a z-score of 1.96, and a confidence level for 99% corresponds with 2.575. So what the heck does that even mean? So if I had something that's normal, so let's say this is going to be my my data of p hats. So we know that p is somewhere in here. Well, a 90% confidence interval just means that I want to be 90% sure that my true value of p will lie somewhere here. Okay, well, how far is this are my upper and lower bounds from my p hat? So this z is just basically a multiplier. It just tells you how many standard errors or how many standard deviations I am away. So every normal distribution, you can try to figure out some sort of z. If I want this to be 95%, that is a certain standard deviation away from the mean. Okay, that's basically all it is. If you have a trouble visualizing, it doesn't matter. You just need to be able to use the formula and know what appropriate z value we want. But z basically tells you how far away you, or how wide or how narrow you want your confidence interval to be. Okay. So let's do a couple of examples. That way, hopefully, it will make a little bit more sense. So here's example number 1. So research has shown that the month of September is where most birthdays occur. We are interested in finding the true proportion of birthdays in September. So notice we can't possibly get every single possible person and try to see how many of them have their month in September. So instead, we are going to sample 100 people. And from the 100 people, we find that 60% of them have a birthday in September. Okay? So what we want to do, based on our sample, we want to find a 95% confidence interval estimate for the true proportion of people who have a birthday in September and interpret that. Okay? So the key words here that you have to really be able to look for is 95% confidence interval estimate. What that tells you is that we're going to be using this formula that I start up here. So we are going to be using p hat plus or minus z star square root of p hat 1 minus p hat divided by n. Okay? So here, p hat is going to be my sample proportion. Okay? So what proportion of people based on our sample said that their birthday was in September? Well, that was given to us as 60%. So that's going to be 0.6. Okay. How many people did we sample? Well, we sampled 100 people. So n in this case is equal to 100. Okay. Now we need to figure out what the z star is. So how far or how wide do I really want my interval to be? So z in this case is going to depend on the confidence interval estimate. So here, my confidence interval estimate is 95%. So 95% corresponds with a z value of 1.96. So this is going to be our z star. So z star is going to be 1.96. Okay? All right, and now all we got to do is just plug everything in. So first, I'm going to do the plus. So p hat plus z star square root of p hat 1 minus p hat divided by n. And we're going to also do the other one, p hat minus z star square root of p hat 1 minus p hat over n. And what I'm going to do, I'm going to plug everything in. So I'm going to have 0.6 plus z star, which is 1.96, square root of 0.6, 1 minus 0.6, divided by n, which is 100. And I'm going to do exactly the same thing with the other one. So this is going to be 0.6. Everything is the same except this is minus. 1.96 square root of 0.6, 1 minus 0.6 divided by 100. Okay, so now let's put all of that into our calculator. So we're going to have p hat plus 1.96 square root of 0.6, 1 minus 0.6 divided by 100. Okay, and what I get from the top one, I got about 0.696. So I got that for the top, and then for the bottom one, I'm going to do the same exact thing, but everything is going to be a minus. So practice this on your calculator just to make sure, because this is probably the hardest part. And the bottom part, I got 0.504 about. Okay, so my confidence interval is always going to start from the lowest number to my highest number. So this is going to be from 0.504 all the way to 0.696. Okay, that is my confidence interval estimate. If you wanted to do it in terms of percent, right, this is just 50.4% all the way to 69.6%. Okay, this is my confidence interval. Now, it says interpret this interval. So what does it mean to interpret? Okay, so let me tell you what the interpretation is. Interpretation. Okay, so every single time that we find a confidence interval, we want to be able to say what exactly this means. So this is really what you want to write. So we will say we are 95% confident, okay, that the true proportion, okay, so we were talking about proportions of what? So let's go back up. The true proportion of birthdays in September lie between 0.504 and 0.696. You could have used a percentage also. So it says we are 95% confident that the true proportion of birthdays in September lie between 50.4% and 69.6%. So basically, we can say that everyone, if we were to sample every single person, our true proportion of people whose birthdays lie in September are between these two numbers. Now, is this true? Well, probably not. If we gather another sample, we might have different estimates because it all depends on what N and P hat is. But that's basically the gist of it. You want to figure out a really good estimate of where exactly the true P will be. We're not quite sure what it's going to be, but it's a really good estimate, and that's what we want. So we'll do a next problem, another problem in the next video.